All right, this is the APB 2.4 equations of kinematics for constant acceleration. And what all that means is that it's we're just adding more equations to our repertoire here. So we only have two equations so far. We have average velocity equals displacement over time, and we have average acceleration equals change in velocity over time. Now, what we're going to do is we're not going to actually do this, but what happens is if you take these two equations and start combining them and just substituting different variables or different things, you'll come up with different equations. And the reason why this is so nice is because instead of having to use these two equations over, many multiple times, all you have to do is use one equation to solve a problem many times. So we're going to take a look at that, what that looks like. So motion equations for an object with constant acceleration. Now remember, this has to be constant acceleration. These are equations. I want you to pause the video and make sure these equations are written down. This one right here, actually, you already have written down. And the other one, average acceleration equals change in velocity over time, you have written down. And these two equations combined together, one way or another, will give you a variety of equations up above. And actually, you already have this one written down as well. So you only have these three equations here. So hopefully you're pausing the video, writing these down. And I'm also going to write down here for you what they all mean. So V means final velocity. V initial means initial velocity. And actually, and so I have acceleration is A, delta x is displacement. Now they also have just plain x. You'll sometimes just see it as plain x as well instead of delta x. And time you'll sometimes see as just t instead of time. And I have the units that are all measured. So you should pause the video, write these down so you know exactly what each variable stands for. And these are just equations we're going to use to help us solve our problems. Make things, it seems kind of more complicated now, but it actually makes things easier. So let's go ahead and take a look at an example here. It says, starting from rest, a car accelerates for 8 seconds to a final speed of 16 meters per second. Find the acceleration of the car and the distance traveled during this time interval. And so what I'm going to do is, the first thing, what we're going to do is, when we approach these problems, is to write down our given. So when they say starting from rest, that means our initial velocity is 0. That's meters per second. Accelerates for 8 seconds, so that's our time, equals 8 seconds. Final speed, that's just v, equals 16 meters per second. And we want to find the acceleration. So so I want you to do is pause the video, see if you can solve this problem, find the acceleration. So we'll use this equation here. The acceleration is the change in velocity or change in time. We'll plug in our values. And we have to remember it's final velocity minus initial velocity. So it ends up being 16 meters per second divided by 8 seconds for an answer of 2 meters per second squared is our acceleration. Now we want to find the distance traveled during this time interval. So that's a delta x or an x that we can use. And now we have to decide what equation we would like to use. So we have to go back, look at our list, look at our variables, and see which one matches up. And actually there's more than one equation that will work in this case because we have 5 variables now. Usually we only have 4 or so. So pause the video, see if you come up with this answer. One of the equations we can use is this delta x equals VOT plus 1/2 AT squared. I can now plug in all the values and come up with my answer. And if you do this correctly, you should have an answer of 64 meters. What's interesting here is you could have done the v squared equals VO squared plus 2AX equation, and that would have worked just as well. But here's an example of what kinds of problems we're going to be solving.